example, we are going to find limit algebraically by factoring the expression first. Part A, we are going to find the limit of the expression 3x squared minus 12 quantity divided by x minus 2 as x approaches 2. This is one of the example of the indeterminate form. As you replace the x with the value 2, let me set on the side here. So 3 times 2 squared minus 12, it turns out to be 0 for the numerator, and denominator, of course, 2 minus 2, also 0. So indeterminate form, I will use the term if. So then we have to simplify it by factoring completely and then find the limit at the end. First, when you have 3x squared minus 12, we see the greatest common factor 3. So 3 times x squared minus 4. And x squared minus 4 is one of the difference of two squares form, or you can recognize it as x squared minus 2 squared. Therefore, it can be factored as x minus 2 times x plus 2. If you guys don't recall, make a note, like when you have like x squared minus y squared, you can make it as a product of x minus y times x plus y. Alright, so we factor the numerator completely, so bring it into the problem. So limit as x approaches 2, the numerator now is factored to be 3 times x minus 2 times x plus 2, all divided by x minus 2. And then we can see the common factor that you can reduce. Now the expression simplified to be 3 times x plus 2. And when you reduce that, basically multiply by 1. When you divide or multiply by 1, you can ignore that part. Our limit turns out to be the limit of the polynomial function. Recall, when you find the limit of the polynomial function, it's the same as finding the function value of that function at the point 2. So we're going to replace x with the 2. So 3 times 2 plus 2, or 3 times 4, it turns out to be 12 as the result for part A. Now move on to part B. Similar fashion, that we have the numerator 2x minus 6. We see the greatest common factor 2, so we factor to be 2 times x minus 3, where the denominator x squared minus 2x minus 3. It can be factored using the factoring skill, like x squared is from x multiplied by x. Negative 3 is from 3 times 1, but the middle term here has negative sign. That means the larger quantity has negative inside. So negative 3 is a product of negative 3 and positive 1. So we can factor this to be x minus 3 times x plus 1. Alright, so we're going to bring them into the problem. We limit x approaches 3. The numerator is 2 times x minus 3. The denominator is quantity x minus 3 times x plus 1. We see the common factor x minus 3 cancel out. That means you can multiply them by 1. And then the simplified form of the expression is 2 divided by the quantity x plus 1. This is not polynomial function, but we can use the substitution technique because the 3 value here doesn't cause the denominator 0. So that means it's going to turn out to be one real number. Otherwise, it's going to be undefined and the limit going to be does not exist. In this case, when you replace x with the 3, the denominator becomes 4. That's a good sign. So now we have 2 over 4, or 1/2 as a result for the limit in part B. Next, we're going to take a look at part C, which requires more algebra skill. So this is the limit of the expression, the function of 7 plus h minus the function at 7. That means we're gonna need, I'm gonna make a note here. So we're gonna need the function value at 7 and the function value at 7 plus h. Alright, let's take care of the easy one. The function at 7, that means wherever you see x, you're gonna replace with the 7. So we have 6 times 7 squared plus 7 plus 1. That turns out to be 6 times 42 plus 7 plus 1. Put in the calculator. We get the value 302. Set it aside. So that term is found. Next, the function at 7 plus h. We're going to treat the input as the whole sum of the 7 plus h. The input square, so that means we put here 7 plus h, plus the input, which is 7 plus h, and then plus 1. And then simplify the power 2 of 7 plus h. Just be careful. We're going to multiply itself twice. That's the concept of the power 2. And then added by 7 plus h and then plus 1. We work out more on this. 7 times 7, 7 times h, 7 times h, and h times h. And at the same time, multiply by 6 out front. So we have 7 times 7, which is 49, plus 7 times h twice, gonna be 14 times h, and then plus h squared, where the last part here, 7 and 1 combined to be 8, and then plus h. A little bit more work to do here. So 6 times 49, that is 294, added by 14 times 6, that turns out to be 84 h, added by 6 times h squared, and then plus 8 plus h. We have light term 294 and 8 combined to be 302. The light term 84h and h becomes 85h, and then added by 6h squared. Now we got the expression for the function at 7 plus h. A little bit more work, huh? Now, I'm gonna bring them back into the main part of the problem. Our goal is to find the limit as the h approaches 0 of the expression, which is the difference of the function at 7 plus h, that what we found as 302, plus 85 times h, plus 6h squared, and then subtracted by the function value at 7, which is 302, all divided by h. Now we got the problem set up. Next, when we look at this limit, as you see, the bottom of course gonna be 0. How about the top? 0 here, 0 here. Yes, gonna turn out as 0 over 0 if we direct substitution in there. So we're gonna simplify the expression that we have. When we take away the grouping symbol, we can see that 302 cancel out. Then we have 85 times h plus 6h squared, all divided by h. That's good news. Both terms of the numerator has h as a common factor. So take the h out. We have 85 plus 6 times h left inside, all divided by h. At this point, we can see that h and h reduce. Now the limit of the simplified expression is limit of 85 plus 6h. As h approaches 0, that's very good because this one now turns out to be polynomial function. For the limit of polynomial function is the same as the function value at the point h equals 0. So then we just plug it in. 0 here, this term gone, and turns out to be just 85 for the result of part C.